dear students, our lesson today is the set of integers, or Z. Now, let's remember together what we have taken in fifth primary. The set of natural numbers, n. n equal 0, 1, 2, 3, 4, 5, 6, and so on. Set of whole numbers starting from 0. The set of counting numbers, C. We start counting from which number? We start counting from 1, and our set of counting numbers starts with 1. 1, 2, 3, 4, 5, 6, and so on. And remember that set of natural numbers, set of counting numbers don't have decimals or fractions. Now, we can say that set of 0 union set of counting number equals n. The new information here that we have numbers which are less than 0. They are called negative numbers. Negative numbers are numbers that are less than 0. We write a minus sign in front of the digits to show that they are negative. For example, negative 6, negative 25, negative 3.2. When we need to use these negative numbers, for example, the temperature over the mountain is recorded 5 below 0. Then it's written negative 5 degree, and this negative 5 doesn't belong to n. Another example, the depth of the ocean at a point is 10 meters below the sea level. Then it's written as negative 10, and this negative 10 doesn't belong to n. So, it's very useful to use new numbers as negative 1, negative 2, negative 3, negative 4, and so on, which are called the negative integer numbers, or Z negative. Here we have the number line. We used to draw the number line starting from 0, 0, 1, 2, 3, 4, and so on. But this year, after taking the negative numbers, we are going to use or to draw the other side of the number line, which is negative 1, negative 2, negative 3, negative 4, and so on. Z positive. Z positive is the set of positive numbers. Positive numbers 1, 2, 3, 4, 5, 6, and so on. Z negative. Z negative is the set of negative numbers. Negative 1, negative 2, negative 3, negative 4, negative 5, and so on. What about 0? 0 is neither positive nor negative. Z. What about Z? Z is the set of integers. What is set of integers? Set of integers is Z positive union set of 0 union Z negative. Which means here we have 0, 1, 2, 3, 4, 5, and so on. From the other side, I have negative 1, negative 2, negative 3, and so on. So, Z equal n union Z negative. Here we have, starting from this 0, here we have the n. N union Z negative will give me Z. Z star. What is this Z star? Z star equals Z positive union Z negative. Or Z star equals Z difference set of 0. If I remove set of 0 from this set, I will find Z star. We know that if we have a set subset of another set, all the time the small set is subset of the big set, and the big set not subset of the small set. Here we have n subset of Z, Z positive subset of Z, Z negative subset of Z, set of 0 subset of Z. So the big set which we have here is Z. And when we have a set subset of another set, the big set intersects the small set, the answer will be the small set all the time. Z positive intersect Z. Where is the small set here? The small set here is Z positive. So my answer will be Z positive because the sign here is what? Intersect. Z negative intersect Z. The answer will be Z negative, the small set. N intersect Z. Where is the small set here? The small set here is N, so my answer will be N. Set of 0 intersect Z. The small set here is set of 0, so my answer is set of 0. And when we have a set subset of another, all the time the big set union the small set will give me the big set. Z positive union Z. Here, where is the big set? The big set here is Z. The sign here is union, so my answer will be Z, the big set. Z negative union Z equals Z, the big set. N union Z equals Z. Set of 0 union Z equals Z. Notes. Z positive intersect Z negative equals phi. We don't have any common elements between Z positive and Z negative, so the answer is phi. The set of the odd numbers union the set of the even numbers equal Z. Set of odd numbers are 1, 3, 5, and also we have -1, -3, -5. Union set of even numbers 0, 2, 4, 6, and also we have -2, -4, -6. If I put these two sets together, they will give me set. Booklet page 3. Represent the following numbers on the number line. We have letter A 4, -2, 0, 1, 5. First, we are going to draw the number line. What do we have? 4. So I'm going to put a dark dot on 4. Then -2, dark dot on -2. 0, dark dot on 0. 1, here is 1. 5, here is 5. And that's it. So simple. Letter B. I want to represent 7, -3, -6, 0, -2 on the number line. So I'm going to draw the number line. 7, here we have 7. -3, here we have -3. -6, here is -6. 0, here is 0. -2, here is -2. And that's it. Number 2. Write the inverse of each of the numbers. Inverse means, for example, here I have 11, its inverse will be -11, and so on. So 11, -11, its inverse. 0, 0 is neither positive nor negative. So what is the inverse of 0? 0 is the inverse of 0. -8. Here we have -8. What is the inverse of -8? The inverse of -8 is 8. 7. What is the inverse of 7? The inverse of 7, -7. -9. What is the inverse of -9? 9. Here we have 12. Its inverse is -12. Here we have -18. Its inverse is 18. Here we have 5. Its inverse is -5. -13. Its inverse is 13. Here we have 15. Its inverse is -15. And the last one is 20. Its inverse is -20. Booklet page 3. Number 3. Complete using the suitable sign belong, doesn't belong, not subset, and subset. Let's remember that belong, doesn't belong when we have the relation between element and a set. Subset or not subset when we have a relation between set and another set. Number 1, Z positive, and here we have Z. This is a set, another set. Do we have all the elements of Z positive inside Z? Yes, we have. So the suitable sign here is subset. Number 2, Z negative, and here is Z. Set and set, we have all the elements of Z negative inside Z, so the relation for the suitable sign is subset. Set of 0, subset of Z. Here we have 0, 0 without any braces, which means 0 here is an element. When we want to represent the relation between an element and a set, we are going to use belong or doesn't belong. Do we have 0 inside Z? Yes, we have. So it will be belong. 2, element, Z negative. Do we have here negative? No, we don't. So 2 doesn't belong to Z negative. Number 6, we have N and N. Any set, subset of itself. Negative 5, Z positive. Here we have an element, so doesn't belong. 17 and N. We can find 17 in N, so belong. Negative 7 and N. Do we have any negative numbers in N? No, so doesn't belong. Here we have set 1, 2, and the other side I have N. Can we find 1 and 2 inside N? Yes, we can, so this is subset. 3 and negative 5, here we have Z. Of course, it's subset. Number 12, 6 and 18, here we have Z, so subset. Here, 9 and negative 11, here we have Z positive. Can we find a negative number inside Z positive? Of course not, so not subset. Half and N. Can we find any fraction inside N? No, so doesn't belong. Number 15, 3 over 8. Here we have Z negative. Can we find any fraction inside Z negative? No, so it doesn't belong. 2 over 7. Here we have Z negative. So we cannot find any fraction inside Z negative, so doesn't belong. 8 over 2. 8 over 2, which means 8 divided 2. Actually, 8 divided 2 equals 4. So here we have a whole number, and we can find 4 inside N, so it belongs. 9 over 3. 9 over 3 equals 3, and we have 3 in Z positive, so my answer will be belongs. 12 over 4. 12 over 4 equals 3, but here we have Z negative. Can we find a positive number inside Z negative? Of course not, so doesn't belong. So here we need to pay attention. When we have small over big in the fraction, no problem, it will be doesn't belong anyway. But when we have big over small, we need to think first. Big over small means I can find a whole number. Maybe the answer will be whole number. So try to divide first. 9 divided 3 equals 3. So here we have the form of the fraction, but the answer is whole number, and I can find it inside Z positive. And so on here in 8 over 12 and 12 over 4. Same idea. So pay attention. When we have big over small, try to divide first. Booklet page 4, number 4. Complete. Letter A. Z negative union N equal Z. Letter B. Set of 0 union Z positive equals N. Z negative intersect Z equals Z negative. N intersect Z equals N. Z positive intersect Z equals Z positive. Set of 0 union Z positive union Z negative equals Z. Letter G. Z equal N union dots. N union what equals Z. N union Z negative will give me Z. Letter H. Z equal what union what union what. Z equal Z negative union set of 0 union Z positive. Z union N will give me Z. Z positive union N will give me N. Letter K. Z positive intersect Z negative equals. Fine, there is no common element between Z positive and Z negative. Letter L. Z positive union Z negative equals Z star. The set of odd numbers union the set of even numbers equals Z. Letter M. The smallest positive integer is 1. The greatest negative integer is negative 1. Absolute value. What do you mean by absolute value? It's the distance from the 0 to the number on the number line. For example, I need to find the absolute value of 3. Here is my number line. How many units from 0 till 3? Here we have 1, 2, 3 units. So the absolute value of 3 equals 3. Okay, another example. If I want to find the absolute value of negative 3, how many units from 0 till negative 3? Let's count. 1, 2, 3. So my answer will be 3. So the absolute value of 3 equals 3. The absolute value of negative 3 equals 3. All the time the absolute value will be positive because distance is never negative. So absolute values are never negative. Page 5, number 1. Find the absolute value of the following numbers. Letter A, absolute value of 9 equals 9. Letter B, absolute value of 0 equals 0. Letter C, absolute value of negative 4 equals 4. Letter D, negative, the absolute value of 12. Here we have the negative outside. Okay, so I'm going to keep it in my answer. Negative 12. Okay, E, absolute value of negative 7 equals 7. Absolute value of 16 equals 16. Absolute value of negative 12 equals 12. Absolute value of 17 equals 17. Letter I, negative, the absolute value of negative 8. So here I have the negative outside, so I'm going to keep it in my answer. Negative, what is the absolute value of negative 8? 8. So my answer will be what? Negative 8. This negative is the sign which is outside the absolute value. Letter J, absolute value of 57 equals 57. K, absolute value of negative 3 equals 3. And L, negative, absolute value of negative 9. What is the absolute value of negative 9? 9. And I have this negative outside. I'm going to keep it in my answer. So my final will be negative 9. Number 2. Determine the value of the integer a in the following cases. Letter A equal absolute value of negative 11. What's the absolute value of negative 11? It's 11, so A equals 11. Letter B, absolute value of negative 3 equals A, which means that A equals what? 3. Letter C, negative, the absolute value of negative 7 equals A, which means that A equals negative 7. This negative, which we already have it outside the absolute value of negative 7. Letter D, absolute value of A equal 33. So this A may be 33 or it can be what? It can be negative 33. because 33 is the absolute value of 33 and it's the absolute value of negative 33. And letter E, absolute value of negative 6 equals A, which means that A equals 6. Page 6, letter F, absolute value of A equals 21. So this A can be 21 or it can be what? Negative 21. Letter G, absolute value of A equals 14. So this A can be 14 or it can be negative 14. Letter H, absolute value of A equals 8. So this A equals 8 or it can be equals negative 8. Number 3. Find the value of x to get a true statement. Letter A. Negative 7 belongs to this set which has negative 2, 8, 0 and x. So negative 7, I must find it here in this set. Can it be negative 2? Of course not. Can it be 8? Of course not. Can it be 0? Of course not. So what is left here inside this set? We have x. So this x equals what? Negative 7. Letter B. 12 belongs to the set which has x, 3, negative 12 and 21. So we must find 12 inside this set. Can this 12 be 3? Of course not. Can it be negative 12? Of course not. Can it be 21? Of course not. So what is left? X. X equals 12. Letter C. 39 belongs to the set which has 3, 9, 39 and x. I need to find the value of x. 39 is here, but at the same time 39 cannot be 3 and cannot be 9, but 39 equals 39. So this x can be what? Can it be 39? Of course not. We cannot repeat the elements. So this x can be any number except 39, except 9, except 3, because we cannot repeat the elements inside the same set. So this x equals any number except 3, 9, 39. It can be 1, for example. Letter D. 24 belongs to the set which has 4, 20, negative 9, x plus 4. So, if this 24 can be 4, of course not. Can be 20, of course not. Can be negative 9, of course not. What is left now? Here we have x plus 4. So, this x plus 4 equals 24. Here, I need to find the value of x. What plus 4 equals 24? Calculate it in your mind. What plus 4 equals 24? Directly, I can find that x equals 20. 20 plus 4 equals 24. So x equals 20. Listed in page 6, letter E. 18 belongs to the set which has negative 81, 8, 3 plus x. So I must find 18 in this set. Can it be negative 81? No. Can it be 8? Of course not. So what's left? 3 plus x. 3 plus x equals 18. Now, what plus 3 will give me 18? If I think and I calculate it with my mind, x will be 15, because 3 plus 15 equals 18. Letter F. 20 belongs to the set which has 12, 2, x minus 40 and 0. Can this 20 be 12? Of course not. Can it be 2? No. Can it be 0? No. So what's left? X minus 40 equals 20. What minus 40 equals 20? The result will be 60, because 60 minus 40 will give me 20. Letter G is cancelled. Letter H. 5 belongs to negative 1, 9, 3, x intersect 1, 0, 5. So what are the repeated elements here? Here I have 5, here I have 5. So this x must be what? 5. Letter I. Here, negative 6, 19x intersect 1, 0, 19 equals 1 and 19. I want to find the value of x. Here is my answer. The intersection between this set and the other set is 1 and 19. Here is 19 and here is 19, and the answer we have 19. Here we have 1, here we have 1. So this x must be equals what? 1. So this x equals 1. Letter J. Negative 3, x 17 intersect 1, 10, 90 equals 10. So here we have 10. The answer has 10. So this x must be what? 10. Letter K. Negative 31, x 77 union 11, 21, 40 equals 77, 11, 21, 40, negative 31, 55. I need to find the value of x. Union means that the answer has all the elements inside the two sets without repeating. So we are going to start crossing the repeated element. Here we have negative 31 and here we have negative 31. Then 77 cross with 77. 11 cross it with 11. 21 cross it with 21. 40 cross it with 40. Now what's left? Here we have x and 55 left in the answer. So x equals 55. Letter L. Negative 93, 47x union 18, 42 equals 42, 18, 47, 30, negative 93. I need to find the value of x. So just like the previous question, I'm going to cross the repeated element. Negative 93 with negative 93, 47 is 47, and 18 with 18, 42 cross it with 42. What's left here? X. And what's left here? 30. So x equals 30.